Okay, good morning students. So good morning students. So today we'll be doing experiment, that is determination of concentration of residual chlorine in given sample of water. I think students that you must be having a basic idea that chlorine is used for disinfection. It is in fact used for killing bacteria and other microorganisms that might be present in water. Okay. So intentionally a little bit of chlorine, that is termed as residual chlorine, is left in the water supply, so that if there is any possibility of any kind of bacteria or other microorganisms that might be present in water could be eliminated. Okay, so that means intentionally a little bit of residual chlorine is left in water supply, but problem arises, excess of anything is bad. Okay, excess of anything is bad, and if residual chlorine concentration exceeds a certain amount, let me say for example the normal amount may be 0.5 mg per liter in water supply. Okay, means a quantity of about 0.5 mg per liter of residual chlorine in water supply is good enough. But if the concentration increases, say 10 mg per liter, 20 mg per liter, like that, it is going to adversely affect the other parameters of water, and aesthetically also it's not good for human consumption and even for animals consumption. Okay, water. So today we'll be determining, or today we'll be learning the steps how to determine the concentration of residual chlorine in the given sample of water. Okay students, so let me I have made you understand about what basically residual chlorine means. So let us see a little background of residual chlorine. So basically chlorination is what? Intentional addition of chlorine in the water supply with the sole purpose of killing the bacteria and other microorganisms which might persist in the water supply. So the chlorination of water supplies and polluted waters serves primarily to destroy or deactivate disease producing microorganisms. A secondary benefit, particularly in treating drinking water, is overall improvement in water quality resulting from the reaction of chlorine with ammonia, iron, manganese, sulfide and some other organic substances. So the sole purpose, I have told you, that to kill microbes, bacteria and other microorganisms that might persist in water supply, that might have escaped the treatment process when the water was given treatment before supply. So chlorination may produce adverse effects. Taste and odor, characteristics of phenols and other organic compounds present in water supply may be intensified. Even if you might have tasted water which is treated with bleaching powder. Bleaching powder is basically calcium oxychloride, CaOCl2, right? So many a times you will see in village areas, in Gram Panchayat areas, open wells are there, right? So that open wells are treated with bleaching powder. Okay, and that bleaching powder basically students that is used for killing of the bacteria and other microorganisms only. ठीक है ना? So the taste is and odor is affected. You will see, or you might have tasted water treated with bleaching powder or calcium oxychloride, and it tastes like anything. Okay, in the initial stage, means immediately after having given a treatment, or suppose we are consuming water after 4 to 5 hours of having given bleaching powder in the water, and it tastes very bad. Okay, and it also smells like chlorine and all, right? So that is why it is written that taste and odor characteristics of phenol and other organic compounds present in water supply may be intensified. Potentially carcinogenic chloro-organic compounds such as chloroform may be formed. Combined chlorine formed on chlorination of ammonia or amine bearing waters adversely affects some aquatic life. So I think I have been able to give you a perception of what residual chlorine is, what chlorination means. Okay, so chlorine is applied to water in its molecular or hypochlorite form, initially undergoes hydrolysis to form free chlorine, just like calcium oxychloride, that is bleaching powder. Ultimately it is going to liberate chlorine. Okay, but before that what happens basically it is added in hypochlorite form. Okay, because in loose form it's not available. So in suppose calcium oxychloride, okay, in hypochlorite form it is added, and gradually it is going to liberate free chlorine, and that is going to treat the microbes and other bacteria. Okay, the relative proportion of these free chlorines forms is pH and temperature dependent. At pH of most waters, hypochlorous acid and hypochlorite ion will predominate. So free chlorine reacts readily with ammonia and certain nitrogenous compounds to form combined chlorine. With ammonia, chlorine reacts to form chloramines, monochloramine, dichloramine, and nitrogen trichloride. So basically chlorine reacts with ammonia, okay, NH4, and it gradually replaces each of the hydrogen ions. Okay, so initially suppose it's NH4 ammonia, then it is NH4Cl, NH4Cl2, NH4Cl3, like that. Okay, so that is nitrogen trichloride. The presence and concentration of these combined forms depend chiefly on pH, temperature, initial chlorine to nitrogen ratio, absolute chlorine demand, and reaction time. Both free and combined chlorine may be present simultaneously. Combined chlorine in water supplies may be formed in the treatment of raw waters containing ammonia or by addition of ammonia or ammonium salts. Okay, so chlorinated wastewater effluents as well as certain chlorinated industrial effluents normally contain only combined chlorine. Historically, the principal analytical problem has been to distinguish between free and combined forms of chlorine. So this was the overview of the background of the residual chlorine. Now let us directly move into the experiment. So what I will do, I'll tell you the aim or the objective. I've told you already. Then I'll be telling you what is the underlying principle involved, what are the reagents that are involved. Okay, then I'll tell you the procedure, how it is done, and after that I'll show you the associated lab video that we have done for residual chlorine, and then we'll see the calculation steps, and then some interference or conclusion that can be drawn from the experiment. Okay, and needless to say, the session will be followed by Google form questions. 4 to 5 questions will be sent to you all, and you all need to respond the questions by 11:30 PM tonight positively. Okay, so students, you know the objective is basically determination of concentration of residual chlorine in the given sample of water, because I told you students that beyond 0.5 mg per liter of residual chlorine is not good. Okay, and that is going to adversely affect the taste, odor, and other parameters of water, and aesthetically also it's not good. So the residual chlorine must be tested, and it must be brought down to the acceptable limit. If we talk about the drinking water standard code, that is Indian standard IS 10500:2012, okay, which is the standard or basic standard code for drinking water in India. Okay, so IS 10500:2012 directly does not prescribe the quantity of residual chlorine, but if you check about chloride, you will see that the chloride concentration has been dictated or has been told in the standard code. Okay, so if you check, you will see that the chloride permissible is around 250 mg per liter. I'm sorry, acceptable, or maybe say desirable, but in absence of alternate sources, maximum 1000 mg per liter of chloride. Please don't get confused between chloride and residual chlorine. The chloride experiment we have done in the previous lab class. Okay, so that is the permissible limit of chloride, but as far as residual chlorine is concerned, the Indian standard code does not specifically prescribe any limit for that, but environmentalists and all the knowledgeable persons who are concerned about drinking water and all, they have concluded that beyond suppose 0.5 mg per liter, okay, or 1 mg per liter of residual chlorine is not good for drinking purpose, okay, or domestic purpose to say. So what is the underlying principle? Underlying principle is chlorine will liberate free iodine from potassium iodide. Okay, chlorine is going to do what? It is going to liberate free iodine from potassium iodide. That means this Ki, the I will be liberated, I will be released, okay, and replaced with chlorine. Solutions at pH 8 or less. So the liberated iodine is titrated with a standard solution of sodium thiosulfate, okay, Na2H2O3, and it is having a concentration of N/50, okay, with starch as indicator. The liberated iodine is directly proportional to the concentration of chlorine present in the sample. So titrate at pH 3 to 4 because of the reaction is not stoichiometric at neutral pH due to partial oxidation of thiosulfate to sulfate. It might be a bit confusing when I am explaining these things, but when I will show you the lab video, it will be more understandable to you all. Okay, so select a volume that will require not more than 20 milliliter 0.01 normality sodium thiosulfate Na2H2O3. For residual chlorine, concentration 1 mg per liter or less, 100 milliliter of sample for chlorine range 1 to 10 mg per liter, and 500 milliliter for chlorine above 10 mg per liter, and proportionally less as per chlorine concentration. Please you will once again go through the literature part that I will be sending to you immediately after the class is over. Okay, so you will see the lab video also, and you will go through the literature so that it is more clear to you all. So as far as chloride is concerned, I have told you in standard IS 10500-2012. Please do remember the name of this code. In many interviews, okay, even in some competitive exams, the question comes that what is the standard code for drinking water in India, and that is Indian Standard 10500-2012. I have told you students, we should not pronounce like 10,500 2012 like that. We should pronounce as IS 10500 2012 or 2012. Okay, in 2012 it was modified. Basically the Indian Standard Code used previously was IS 10500 1991, and it was modified and some aspects were redefined, okay, some new things were added, and that was composed in 2012, IS 10500 2012. So as far as residual chlorine is concerned, the code specifically does not prescribe any limit, but as far as chloride is concerned, the code says acceptable limit for chloride is 250 mg per liter and permissible limit is 1000 mg per liter in absence of alternate sources, but residual chlorine specifically is not prescribed. Okay, so what are the apparatus and reagents? Apparatus, basically students, it's a titration test, so we will need burette, we will need pipette, okay, we will need beakers, flasks, conical flasks and all, you know. And reagents or chemicals that are going to be used is acetic acid, okay, then potassium iodide solution, then standard sodium thiosulfate solution, okay, starch indicator is going to be used, standard iodine is going to be used, and diluted standard iodine also is going to be used. Okay, so there is a long list of reagents, okay, that is involved in the experiment. So how do we perform? Basically the volume of sample we take, right, in which the chlorine has to be tested, residual chlorine has to be tested. So select the volume that will require not more than 20 milliliter of 0.01 normality Na2H2O3 and not less than 0.2 milliliter for starch iodide endpoint. For a chlorine range of 1 to 10 mg per liter, use a 500 milliliter sample, and above 10 mg per liter use proportionately less sample. So we prepare for titration. You know the titrant is standard Na2H2O3, that is sodium thiosulfate solution, that is going to be put into the burette. So place 5 milliliter of acetic acid or enough to reduce pH. We will try to maintain pH between 3 and 4. Okay, so that is why we use acetic acid, okay, that will maintain pH between 3 and 4 in a flask or white porcelain casserole. Add 1 gram of potassium iodide estimated on a spatula and pour sample in and mix with stirring rod. Okay, then titrate away from direct sunlight, because you know in any of the chemical, or if you also use medicines and all, you will see that it is written store in a cool and dry place. So the titration should be done away from sunlight, direct sunlight. Okay, so add 0.025 normality or 0.01 normality Na2H2O3 from burette until yellow color of the liberated iodine almost is discharged. Okay, and 1 milliliter starch solution and titrate against Na2H2O3. Okay, with a 1 liter sample, 1 drop is equivalent to 50 gram per liter. Right. Then let me show you the video to make it more clear. Right. Sorry. Video. So it buffers a lot, that is why I'll narrate it, the experiment. So we are going to use basically students N/50 Na2H2O3, glacial acetic acid, potassium iodide solution, starch solution and chlorine solution, as I have told you. Right. So what we will do initially, we'll be taking 50 milliliter. Suppose this is the flask. Okay, we'll take 50 milliliter. Okay, 50 milliliter of chlorine solution in this flask. In the conical flask, we will take 50 milliliter of chlorine. So see, the chlorine is being poured. 50 milliliter of chlorine is being taken into the conical flask. So this is 50 milliliter, markings are there, right? And then potassium iodide solution of 5 milliliter. To ensure that 5 milliliter is taken, we take graduated cylinder. Okay, we'll ensure that 5 milliliter of potassium iodide is taken, not more than that. To maintain accuracy, we are using graduated cylinder. So it is 5 milliliter. Okay, we'll be adding that potassium iodide into the chlorine solution and we will mix it properly. A brown color solution will develop. See, the color has changed into brown color. Okay, so the brown color is developed, right? Then this is glacial acetic acid. Okay, because we'll try to maintain pH between 3 and 4. So we are pouring 3 to 4 drops of glacial acetic acid, which will try and maintain the brown color as well as the pH between 3 and 4. Okay, so we are mixing properly so that pH is maintained and the brown color is also maintained. Now we will be titrating against standard Na2H2O3. Titration should be done slowly and mild rotations or movement should be given to the flask so that it mixes properly. Right? We will note down the initial volume. Please don't forget to note down the initial volume of sodium thiosulfate in the burette. So see students, the color is changing. It will change to straw yellow color. जैसे कि भूसा बिचाली होता है ना, straw, उस कलर का जो है light yellowish color will be developed. देखिए धीरे धीरे, this is the basically straw yellow color that is being developed. Right? Now we will do what students? We will add starch into it. Okay. We will add starch into it. We will add 1 milliliter starch solution. This is starch. Okay. This is the indicator. Basically, we will add 1 milliliter of starch, and it will change into the straw yellow color will change into blue color. आप देखिएगा जैसे हम ऐड करेंगे blue color develop हो जाएगा. When we will be putting in 1 milliliter of that into the previous solution, which is straw yellow in color, it will change into basically blue color. ये देखिए ये blue color develop होने लग गया. This is the blue color that is being developed. Okay. Now again students, we will titrate it against the standard Na2H2O3 solution. Sodium thiosulfate solution के against एक बार फिर हम जो है इसको titrate करेंगे. And we will continue the titration till the color disappears or it becomes transparent. And we will note down all the volumes. Okay. Initial volume of sodium thiosulfate in the burette, right? So this is the transparent color that has developed when we have titrated against standard Na2H2O3. So we have noted down the initial volume of Na2H2O3 in the burette. Then when the color had changed to straw yellow color, we will note down the volume. Again, when we have added starch, 1 milliliter starch solution indicator, and it has changed into blue color. After that, when it will turn into colorless, we will again note down the volume. So I think the procedure is clear to you all. Now let us go to the calculation part. So, and once we will do it for sample, okay, and second time we will do it for distilled water, so that a blank, we use the same proportion or same quantity of distilled water in another flask as much as the quantity of sample water is taken initially. Okay, उतना ही हम जो distilled water ले लेते हैं, which is treated as a blank and which is used as a check. So for standardizing chlorine solution for temporary standards, okay, mg per liter of chlorine as Cl2 per milliliter is equals to A plus minus B into N into 35.45 divided by ml of sample taken. ठीक है, and for determining total available residual chlorine in water sample, we write it as A plus minus B into N into 35450 per ml of sample. Now the question arises, what is this A? A is basically ml of titration for sample. What is the ml of titrant that has been used for titration of the sample? ठीक है ना? What is this B? B is equals to ml of titration for blank, that is the distilled water. And what is this N? N is the normality of Na2H2O3. We have used N by 50 normality. Okay, so we'll put the values in this and we'll get the amount of residual chlorine present in the sample. Okay, so interferences, oxidized form of manganese and other oxidizing agents interfere. Okay, reducing agents such as organic sulfides also interfere. Means these can create problem in the determination or in the titration experiment. Although the neutral titration minimizes the interfering effect of ferric acid and nitrite ions, the acid titration is preferred because some forms of combined chlorine do not react at pH 7. So we use only acetic acid for acid titration. Sulfuric acid will increase interference, so sulfuric acid and as well as hydrochloric acid HCl should not be used. Minimum detectable concentration is approximately 40 gram of chlorine as chloride Cl2 per liter if 0.01 normality Na2H2O3 is used with 1000 ml sample. Concentrations below 1 mg per liter cannot be determined accurately by starch iodide endpoint in this method. ठीक है, if the concentration of chlorine is below 1 mg per liter, then it is very difficult to determine by this starch iodine method. Okay, so that's all for today. Thank you so much everyone. Please take very good care of yourselves. The session will be followed by Google form questions. You will be getting 4 to 5 questions. You please respond by 11:30 PM tonight. So thank you so much everyone.